Once again, welcome to the channel Unknown Warrior. So, we are going to see today software engineering concept. And this, we are going to see the introduction to software engineering, in which we are going to study what do we mean by software, what do we mean by software engineering, then its characteristics, then different layers of software engineering. Then next is the software process models, etc. So today's focus is on the introduction to software engineering. So basically, what is a software and where we are using them? So basically, software is nothing but the set of instructions or the set of code which are built by using some data structures and by using some documentation and models. Basically, we are very much familiar to these applications or we use these applications in day-to-day life. For example, Microsoft Office Suite is the so inbuilt OS applications which are used in Microsoft. Okay, so these are some, for example, next are the Photoshop. Then we use Google Pay, then Google Play, as well as we use some other softwares like Android, Amazon, Chrome, Edge, etc. So all these are nothing but the examples of software, and each one can be either generalized or specialized. We are going to see what do we mean by generalized software and what do we mean by the specific applications or software. So let's get started by the definition of the software. So software is the set of instructions that is nothing but computer programs that when executed provide desired features, function and performance. Next, it is a data it includes the data structures that enable the programs to adequately manipulate information and documents that describe the operation and use of the programs. Basically, software is nothing but the set of instructions and it utilizes data structures and uses documents that describe its operation and use of the programs. This is the actual technical definition of the software. So the main keywords here are the instructions, data structures and documents. Next is what is actual software engineering. Software engineering is defined as the process of analyzing user requirements and then designing, building, and testing software application which will satisfy those requirements. While developing any software or any application, the main goal or the main aim is nothing but the customer. So without the customer requirements, none of the application is going to be implemented. And even though implemented, it will not guarantee you the income or we can say any profit. So that's why while developing any software, we need some user requirements. Then after taking those user requirements and analyzing them and finding some useful features to start with the development of the product, then before developing the product, what we do is we do designing of those requirements, and after developing the product, what we do is the testing of our software and checking whether it satisfies the user requirements or not. So basically, this is nothing but software engineering, and in the easiest way, we can say it is the study of how to develop a particular software. But in technical terms, this is the definition for software engineering. Next is let's see the characteristics of good software. So the software is classified into six major components so that we can, after analyzing the statistics of any application, we can say that our software has reached at the highest quality or the we have been developing the high quality product that can increase the productivity rate or the profit of the organization who has been implementing this product. So basically, the software which is of high quality, we can ensure that it has all the following characteristics in it. So let's see one by one. First one is nothing but functionality. So in this functionality characteristics, the main focus is on the performance of the software. That is, if for the given, after analyzing the user requirements, whatever features we have generated and we have designed the model, is our system working exactly as per the design model of the requirement. If it is having no errors or any mistakes in the implementation, the product is working exactly how the user wants, then we can say that our product is functioning properly without any defects. So basically the performance consists of the parameters such as accuracy, precision, security, reliability, and the final result it generates. Second one is nothing but the reliability. That is our application able to be trusted? For example, we can take the ATM machine. So the ATM machine should be reliable. That is, the users using those machines should have trust on them. So how they can trust those system or those software is they provide some secure measures in it so that the user data is not leaked and data is not handled by any intruder. So these measures should be included into your software. Then and then only you can see that the software which we have developed is reliable for the user. It covers the recoverability, that is, if there are some errors or the faults or any damage which happens to the software, it is easily recoverable to its original form. And second one is the fault tolerance, that if the fault occur, it is the system or the product or the software can handle those faults. Third one is efficiency. So efficiency means that while developing the product, whatever resources we have used and the time span which we have been given for the which we have invested in developing that product is truthful or fruitful. That is, it refers to the ability of the software to use system resources in the most effective and efficient manner. So let's say that I have taken some resources for developing my software, and at the last I found that some of my resources are still gone wasted and I have not completely utilized the resources for my software development. So it impacts the user that we while calculating the cost estimation, it will be observed that the cost which the organization has set up is not worthwhile, as we have wasted too much money in the resources which we are not requiring for developing the product. That means that if we say that the efficiency of the system is high, it implies that we have utilized the resources completely for the development of our product, and the cost which was the cost which was put for the resources is truthful, and hence we can say that the system is having high efficiency. So the main term here is the to make the effective use of the resources and the storage space and the time which we have spent for the development of the product. Fourth one is the usability. So usability refers to the extent to which software can be used with ease, or the amount of effort or time required to learn how to use the software should be less. Let's consider one application. which is, let's say, game application. So as a child or as a teenager, once you are given that game, you can easily understand the steps, that a few steps to be followed for either, say it is some fighting game, so which arrow keys or the number keys should be pressed for that particular moment. So you easily get adapted to that game. That is nothing but the usability. So your application should be easy to use for the customers and not time consuming for the customers to think that which key or which touch is to be applied for the particular operation. So it covers understandability, learning ability, and operability. Fifth one is the maintainability. So I have already discussed that if any problem occurs in the system or a software, so they should be easily maintained or controlled by the organization or by the software itself. So it refers to the ease with which the modifications can be made in a software system to extend its functionality, improvement, performance, or correct errors. It covers testability, stability, changeability, and analyzability. The main concern with the maintainability is if some fault occurs, the system should be easily recoverable by the system itself or by the organization which has developed that particular software. Or the second reason may be that user has given some feedback in which the functionality of the system needs to be improved. In that case, also the system should be easily reusable for extent of functionality and improvement in it. Sixth one is the portability. Portability, let's say, we in the ancient times or in the 19th century, most of the people were using the desktop computer for their performing some task. Whereas as the ages or as the years passed, more of the focus was on either mobile smartphones or the laptops. Why? Because the laptops or the smartphones were easily able to be carried around, whereas for the desktop computer we have to sit at one place and operate them. So this is nothing but portability. That is, it bears the ability of the software to be transferred from one environment to another without or minimum changes. So as I have talked about the hardware, similarly in software, it is that, for example, let's say if I have developed the application for the Windows, so it should also work with the same functionality in other operating systems. This is nothing but the portability in software. So it covers what? Adaptability, installability, and replaceability. Seventh one is nothing but robustness and integrity. So robustness is refers to the degree to which the software can keep on functioning in spite of being provided with invalid data. So let's say that if, for example, that I am facing some problem or I am providing some invalid data, the software should either give you a prompt that this number or this sentences should be entered. Let's say for the login page, if you entered the incorrect password, that is nothing but invalid input, the system should give the user some notification that saying that you have entered the invalid username or password. This is nothing but robustness. Integrity, it refers the degree to which unauthorized access to the software can be prevented. Integrity means some, for example, as if I am providing some security measures for my email account, then if someone else is operating the same email account with the new device, so here the system or the software should prompt me that new browser identified, and please confirm that you are the one who is accessing that application. This is nothing but the integrity. Now let's focus on the types of software. So in previous all studies, there were mainly two types of software. Those were system software and application software. The system software was used to control the internal computer operation. So the best example for this is the operating system. And application software carries out necessary operation for a specific application to function. The best example for application software is Microsoft Windows Office suite like Word, PowerPoint, Excel. This is the best example of application software. So these were the basically two types of software in previous studies, in which the system software was again divided into two parts, that was system management program and developing software, in which system management program consists of the softwares like operating system, device drivers, system utilities, and developing software include programming language, language translator, linker, and loader. Basically, the system software focuses on in what internal computer operation organization. Second one is the application software. So it was divided into two types, that is general purpose and specific purpose. General purpose, that it can be used for any type of working. That is, let's say examples are a word processor, then presentation, spreadsheet, image editor. This can be used for any other type of working. It can be used either in, say, education purpose, in office, or in any other work. So these are nothing but general purpose software. Anyone can use them. Specific purpose is the application which are specially developed for particular domain. So here you can see the examples are reservation system. So it can be railway reservation system. Attendance system is designed only for maintaining the attendance record, billing system, report card generator, etc. So these are nothing but special purpose software. So these were the only two applications in previous studies, that is system software and application software. But nowadays there are more and more softwares included in the types of software. So let's see which are there. So this is the broad view category of the types of software nowadays. So it includes obviously system software and application software. And what are the other domains we can say, or the applications which are included are engineering or scientific software, embedded software, product line software, web application, artificial intelligence software, and there is one more, that is open source software. So we have already studied the system software and application software. And what are the engineering or scientific software? So these applications or software which are specially designed for the engineering faculties or the people who are working in engineering field are the only persons who are using this software. So let's say for example, that is AutoCAD application or software is mainly used by the persons who are in the field of designing of the product. Those persons use the software called AutoCAD. So this is the example I have given for the engineering and scientific software. Next one is the embedded software. So basically these software are designed to handle both software as well as hardware part. That is, let's say the example as IoT, that is Internet of Things, in which all the devices or applications are connected to each other in the form by the internet. This is nothing but IoT. So to do this communication, to communicate each component with each other another, we require some embedded software. So the best example for IoT is the Arduino IDE. This is the software which is used to communicate or combine the software and hardware for some task. So this is nothing but comes under embedded software. Next is the product line software. So these softwares are mainly used in factories such as car parts manufacturing company. Next is the food factories, in which the food from raw material to the final touch are all done by some software or by done by some robots which are handled by some software. So these are the examples of the product lines of. Next is web applications. This is the familiar applications we are using nowadays, and those are nothing but Chrome, in which we are using Google browsers, Yahoo, etc., Bingo, etc. Okay. Next is the artificial intelligence software. So basically, this artificial intelligence software and product line software, the difference between them are product line means what? That for developing the products which start from the raw material and till the we have to achieve the final touch, they pass through some certain stages. So here the softwares which are used are what? Product line software. Whereas they are included in as well as in artificial intelligence software as well. So basically, let's say that there is, if we want to develop a robot, so for that we require there are some specific applications that are actually designed for developing the robots. So these are nothing but the artificial intelligence software. And the next one, which I have not mentioned here, is the open source software. So there are basically two types, that is open source and free software. So I have asked my students many times that what is the difference between the open source and the free software. So I've given them these tasks for finding the difference, and as they have come with various answers, but as per my view, the open source and free is nothing, whereas free means you can download it but you cannot manipulate that software. This is nothing but free software. Whereas open source means what? You can freely download the application or software and you can modify it as well. So this is the difference between the open and free software. So here the type of software we include open source software. So these are the examples which we have discussed while studying the types of software. So let's just revise it. The first one is a system software. Its example was operating systems such as Windows, Ubuntu, Linux, Macintosh, etc. Different servers. Then second is the application software. We are saying Microsoft Office Suite. Then specific applications like reservation, then attendance, etc. Third one is engineering or scientific software. I've already told you AutoCAD. Then there are MATLAB, Android Studio, etc. Fourth one is the embedded software. So applications such as MP3 player, Arduino IDE come under embedded software. Fifth one is the product line software. So these are used in car or food companies. So sixth one is the web applications, which is nothing Google, Yahoo, etc. Artificial intelligence software. So here the software named as AlphaGo is can be used for the artificial intelligence software. Then open source software, so operating systems and database management system software. So open source software, we can have the simple example of OS such as Ubuntu, which is open source. These are the examples of the types of software. Next, we are going to see that software engineering as layer approach. So what is the main focus while developing, or what is the process while developing the software? So there are total 3 layers of software engineering or approach for software engineering. So that is the main concern is here is the quality focus, and the process, methods, and then the tools. So first layer is nothing but the quality focus. That is at the start when we have received the user requirements, from that point the concern for developing the product or the application is we have to achieve the highest quality product at the final results. This is nothing but the focus on the quality. Second is the process. Now if we want the highest quality product, so how we can achieve that goal. So we are implementing some procedures, or we are making some designs out of the requirements, and we are starting the development part of the product by considering those application models and the plan that includes the processes which we are going to follow, that the product which we are developing has no faults, is completely within the deadline, and the cost with concerned with that product is proper. So after considering this all parameters, and by fulfilling these parameters, we can say that we have achieved the quality focus. So that's why the second is the process. Third one is the methods. Now methods means what? That either we are going to implement or develop the product by using certain strategies. Let's say that if we are developing the program for the application, then we can say that if we are using some programming languages for developing it, so which programming language should be used so that the time for developing is gets minimized and we get the optimal results. This is nothing but the methods which we are going to consider while developing the software. Next is the tools. So tools, we can develop a certain product by either simply doing all the coding by the developers, or 50% actual coding of the program is done by the developer itself, and 50% the developer takes the help of the automated tools which are already been designed while developing, or we can use 100% automated tools for designing the product. So this all is nothing but the tools. So let's say for software testing, there are many such tools that are used for testing the product. So those are nothing but we can say Selenium, then there is WinAuto tool, so by which it generates some test cases, some flow charts, and some process so that the tests can be get minimized, or we can also write some exceptions in our program so that we can directly get the statement where the error has occurred or the fault has occurred. Basically, the main motto of the testing tools are nothing but to find the errors in our code. So this was all we have discussed. I have just mentioned here the steps. Now we are heading towards the process models, that is nothing but software process models. So after getting the user requirements, we are designing some procedure for implementing our product. So what are these procedures? So for that, certain models are designed. So first, let's take the model as prescriptive model. The main focus of the prescriptive model is the step-by-step designing of the procedures which we are going to use for the development of the product, that is from taking the user requirement till the deployment of the product to the users. So there are many such models by which we can minimize the faults, and we can take the user feedback and work on it again by generating the next version of our product. So first of all, we are going to see prescriptive model. That is, again I will repeat, it is the step-by-step implementation of our product. First one in prescriptive model is nothing but the waterfall model. So waterfall model is the simplest model of all other models in software engineering, which includes the stages or paths like communication, that is nothing but requirement gathering from the customers, planning, which includes estimation, scheduling, tracking, that is estimation. We have already studied in the previous lectures, we have used the COCOMO model. Then scheduling, that which task in the developing should have how much time for its completion. The tracking, as we have already studied, checkpoints are set while studying SQA, that is software assurance, quality assurance and quality control, and RMM model. I have already discussed this point, that what are the checkpoints. So basically, I'm again telling you the checkpoints are nothing but say that after stipulated time, I want to check that whether my product, which is in the developing phase, is working as per the user requirement or not. So this is nothing but the tracking. Okay. The third one is nothing but modeling. That is, we are doing the analysis of the requirements, analysis of the plan, and we are designing some components regarding that requirements. So basically, in modeling is nothing but the system architecture, UML diagrams. UML diagrams are unified modeling language design. Okay, so these are nothing but UML diagram. Next is construction. So basically, modeling includes system architecture and UML diagrams. System architecture, which shows the relationship between all the components, or we can say features of the system, and each component can be developed differently, okay, by different teams of the development team. Okay, next is the UML diagram. So UML diagram is nothing but it tells the in-depth procedure, that how the coding, or we can say the flow of the development, is to be done. Next, the fourth stage is the construction, that is the actual development of our product, that is coding and as well as testing. So after the finding the errors and solving them, we are handovering, that is nothing but deploying the product to the users. So in deployment phase, it includes delivery, support, and as well as we take certain feedbacks from the customer regarding that software. The advantage of this model is that it is easy to be implemented, easy to use. It has fewer steps, right? When it is, we can say that as a new or the startup companies mostly go with this diagram, as they have less knowledge in the maintaining the quality of the product. That's why they start with the basic. They want to start with the basic model. So basically, they start with this waterfall model. What are the disadvantages regarding this waterfall model? So waterfall model is easy, but if we deploy, as you can see, if we deploy and the users send us some feedback regarding our product, then again we need to start it from the communication phase, then planning phase, then modeling phase, then construction, then deployment. That means if I have required 1 year for the completion of the certain product or application, then again after getting the feedback and again I have to work for again 1 year, or say if we require half year for the generating the second version of the same application, which means that we are wasting too much time for the same product. So to overcome this time consuming problem, the second prescriptive model is the increment model, which has same phases as the waterfall model, but here what it is done, it takes the user feedback at each stage or each phase of the procedure. So let's see that if first increment, that is the first waterfall model we have implemented, so we are in the communication phase. So while we are in the communication phase, that is we are taking user requirements, and after taking the user requirement, the this procedure has come to the second phase, that is nothing but planning phase. And while we are in the planning phase, we found that some user requirements are missing. So why un, so some sorry so some there are some misplaces, or some communication is misplaced while taking the requirements of the user. Then without disturbing the ongoing process, we start with the second process from the communication by taking the mislead or misplaced requirements and start with the second incrementation of the second development phase version of the product. So as you can see, For example, now we in this phase or this process, we are at the planning phase. Okay, and as we have found that there are some drop or misleads in the first, that is communication phase, so we have involved it in increment 2 without disturbing this process. So the planning phase will go towards the modeling phase, whereas the increment 2 will be incremented in planning phase. Okay, then again we have found that the communication is changed over here, then we will go towards the incrementation of third process. So here, as we can see, the increment first will be delivered obviously first, then the second, and then the third. So here, what we are doing is we are not waiting for the user feedback at the last. We are taking the user feedback at each phase and we are implementing it at, or we are starting the implementation of the second version at that particular time only. So here, if I am requiring the 1 year time span for the first increment or first version of the process, then after taking the user requirement and again developing second, so here for the increment 2 I will require only few months for the version 2. Similarly, if there are again changes, the increment 3 is simultaneously generated and it will require some few months for handovering the product to the customer with the changes. So incremental process model is the advantage over the waterfall model, that it uses less time for the development of next to next versions and all the works are being done parallelly in incremental phase. So here as we can see, it is the software functionality and feature by project calendar time. So here project calendar time is, as we can observe, it is somewhat to the constant, whereas as we are incrementing each layer, so here the functionality of the software goes on increasing, but the project calendar times remain constant or linear. This is nothing but the advantages of incremental model. But here, as you can see, that here the same, that from the starting till the end, we are going through the same phases. And if I want to increment the fourth one, then I have to start with the same process. So this is nothing but the disadvantage of the incremental model. So here, so the disadvantage of the incremental model is that a single testing team handles all the process of implementing the software. That is, either it is handling of iteration 1, iteration 2, iteration 3, all is done by the single testing team. So this disadvantage is overcome in the rapid application development model, which is the third model in prescriptive model. So in this, the also the increment model does not have any deadline that the product should be developed within the particular time span, whereas in rapid application model the time span is given, that is between 60 to 90 days the whole product should be completed. So it includes the phases as business modeling, data modeling, process modeling, application generation, and testing and turnover. And here, the each process is handled by the different teams. So basically, for example, some organization has the development teams. The development team is again divided into partition into different parts or to handle different versions of the product. So that's why here we can see that each increment is handled by the different team, that is team 1, team 2 and team 3. But to develop each version, it should be completed within 60 to 90 days. This is nothing but rapid application development model. So we can show the model in either in this representation or either in this representation. So it is same, that requirements are taken, then the modularized requirements, that is the finalized requirements, then these requirements are subdivided within the teams, It is team 1, team 2, team up to team n. So team 1 will handle the model 1, team 2 will handle the model 2, and team n will handle the model n. And this development phase includes analyze, designing, coding, and testing part in it. That is, to develop particular model, we have to first analyze the requirement, then we have to design, that is system architecture and the UML diagrams, then we have to develop or code the application, and then finally test that module. Again, what we are doing is we are integrating all the modules or the components of the application, and we are again doing the final testing part and delivering the product to the user. This is nothing but the generalized diagram of the radar model. So we have seen the three different models in the prescriptive model of software process models. Second process model is evolutionary process model, in which evolutionary process model are basically the models which are in cyclic functioning. That is, each phase is connected with the next phase in the model, and it forms a cycle, and the process goes on till we achieve the best quality product and the user requirements are satisfied. So this process goes on and goes on till we get the final non-erroneous product. So first one is the prototyping model. So prototyping model has phases as communication, quick design, modeling, quick design, then construction of prototype and deployment. So as you can see, it is in a circular fashion, right? So after communication, we are doing the quick design of the requirements. Then after quick designing of the model, so we are modeling quick design. That is, here in quick design we include system architecture, whereas in modeling quick design we include the UML diagrams as well. Then after doing this, we are constructing the prototype, and according to that prototype, that is system architecture, we are delivering and deploying the developed product. This is nothing but the prototyping model. And after development, if we take the user feedback, and if there are some changes or some errors, and we found that there are still some errors in the product, then again we give it to the communication phase, and this process continues till we get the best quality product. So this is nothing but a prototyping model. Next is the spiral model. So spiral model is the model as shown, as you can see. It starts with the communication phase from its center part, and then after completing of the communication, it is given to the planning phase, then modeling, then construction, then deployment. After deployment, if there is some feedback, again the communication is done, and again planning, then modeling, construction, and so on. So it tells us that we started with at a particular point, that is from the first part, that is communication, and we have again reached to the same part, that is communication. So we here you can see that we work in the spines. That is, if we have completed one spine, then again we are not doing the same work, we are continuing only with the feedbacks of the customer. We are not again taking the user requirements fully, user requirements, and again we are doing the designing part and so on. So this is nothing but the spiral model. Next one is the concurrent development model. So in concurrent development model, first phase is the inactive phase. That is, there is no user requirement till now. Once the user requirement is achieved by the customer, sorry, by the organization, so we start with the development phase. So the status for the product is under developed. So if once the product is developed, and if still there are some changes, then it enters in the awaiting changes state. Whereas if it is developed, then the stakeholder puts the product in the under review phase. So here we can see when still there are some changes to do in the development phase or in the product. So it is under what? Awaiting changes. And after doing those changes, then the product enters in the under revision state, or it is also known as under review state. Okay, so this was what? Awaiting changes. If the product has no changes, then it is put under the review category, which is done by the stakeholders. So if the stakeholder found that there is no change, then it passes the product in the done phase. Whereas if it finds that still the user requirements are missing, then it puts it into the phase of baseline. And once it is seen by the stakeholders that now is the product meets the user requirement, then it puts the product into the done stage. And after done, if the user sends some feedback that where the changes are needed, then again the status of the product is reached in the awaiting changes. So the blocks here represent the state of software engineering activity. So this is nothing but the concurrent development model. So these were the all evolutionary process model. The first one was prototyping model, spiral model, and concurrent development model. The third process model is nothing but the specialized process model. So in specialized process model, there are different phases. Those are component based development, which means that process to apply when reused in a development object. B is what? Formal methods model. It emphasizes the mathematical specification of the requirement. That is, let's say the application which we want to build is the calculator. So in which we require, if it is scientific calculator, we require many mathematical equations to be included in our code. So this is nothing but formal methods model. Third one is aspect or sized software development. It provides a process methodological approach for defining, specifying, designing, and constructing aspect. Fourth one is the unified process. Unified process is the diagrammatic representation that shows process or product while developing the software. So unified process mainly uses what? Diagrammatic representations. So these diagrammatic representations are known as UML diagrams, that is Unified Modeling Language Diagrams, which shows us the actual working of our product or a software, and what are the phases and process, or what are the components of the system in detail. So these are nothing but UML diagrams, and all these steps are included in specialized process model. Next one is agile software development. This is the fourth process model and widely used in many organizations. The why this agile software development is so focused or widely used is because it provides us the process or the procedure for developing a particular software in quick and easy manner, and that's nothing but the definition of the agile. So agile methodology provides requirements and optimized solution, then provides the methods for development of project, and has functional teams. Next, the word sprint in agile means is a set period of time during which specific work has to be completed and made ready for review. And this is the best, or we can say the advantages of agile software development over all the other software process models. That is completing the product within the time by using some easy techniques and by by the strategies used for the implementation. So basically the agile development includes developers, testers, business analyst, scrum master, build engineer, architect, and product owner. So there are 12 principles of features of agile. First one is highest priority is to satisfy the customers. The goal is to satisfy the customer, that is to meet the high quality product. Second is welcome changing requirements even late in development. That for say that we have reached till the end of the development phase and the users are developing some pressure over the organization to make changes in the requirements. So as we are working in the agile methodology, so these changes are always welcome because the strategies used in agile are somewhat different. That is, they use simple techniques and some unique models so that at any phase of the development or any phase of the software development, the user requirements changes are welcome. Third one is deliver working software frequently. As soon as the product is developed, it is handed over to the customer without any delay. Fourth one is business people and developers must work together daily throughout the project. That means that, for example, I am a developer and at daily basis the stakeholder or the business people should or are interacting with the development team members so to get the status of the development of the application. That is nothing but the advantages of agile. Fifth one is build projects around motivated team individuals. That is, all the team members should be should have some motivation to while developing the product. The focus should be of getting high quality and each member in the team should understand each other very well, and to do that it should have some well communication part within them. So the product should be built in the motivated team. Face to face conversations, obviously we can have virtual, but the main concern in agile is to face conversation and discussing the advantages or some back through of the product which we are developing, and each one should give some proper suggestion regarding them. Seventh one is the working software is the primary measure of progress. It is not that we are building the product in easy and quick manner, which means that we can quickly develop any sort of software and hand over it to the user. But while handovering, should be in working state. Agile processes promote sustainable development. Ninth is continuous attention to technical excellence and good design enhances agility. So as we have seen, the designing part includes system architecture, then UML diagrams, and this process models. So all these are nothing but the designs involved while developing a particular software. So this design should be good and proper so that we can achieve all the requirements in the final product, as well as it is completed within the deadline and it is working properly. The 10th one is the simplicity, the art of maximizing the amount of work not done. That is, the work should not require maximum time for the completion. It should be somewhat simple, and it is essential. Which means that, for example, to select one programming language which will do the work within, or we can say within the deadline, and not require too much time by playing with only the coding part. So let's say that we are going to use some programming language which utilize less lines of code, it's LOC. Okay. 11th is that the best architectures, requirements, and designs emerge from self-organizing teams. So your self-organizing teams means, for example, we say there are team 1, team 2, team 3, and team 4, and they are working in their particular product. But if team 1 member wants the help of team 2 member, so they should be adjustable to work and help each other so that the work gets done within the deadline. So this is nothing but self-organizing teams. At regular intervals, the team reflects on how to become more effective. That is to learn new upcoming strategies and implement them in the developing process or software. So first model in agile process model is the XP, that is extreme programming, which includes the coding part. And after coding, if we have some drawbacks or the feedback from the user, then the steps are as release plan. So if the plan is released, then within the months, the second iteration plan should get started and it should be completed within the weeks. Then we have to do the acceptance testing on the product which is developed, and the acceptance testing should be within the days. Then after acceptance testing has been done within the days, then after few days there should be some stand-up meetings of the testing team as well as developing team with along with the stakeholders, then business people and all. So after acceptance test within the few days stand-up meeting should be held. Then after this stand-up meeting within the 1 day, the pair negotiation, that is stakeholders with the other team members, must be done. And after that within the hours there should be unit testing, that is the each component of the product is to be tested so that if there are some errors in the product that can be get solved. And after that solving within the minutes, pair programming, that is each developer should solve that error within the minutes. And after that the code is completed and hand over to the user. And again if the user sends some feedback, then whole the process is again repeated till we get high quality product finally by comparing it with the user requirements. So this is nothing but extreme programming, that is planning and feedback loops. The second model is the Scrum model and it is also widely used in the organizations. So here the first of all the Scrum model is basically used when there are some or in changes, repeated changes in the product as the user requirements are changing. So it includes all the customers, stakeholders, product owner and the team, which is of 5 to 10 people. They are cross functional, that is the members can work within the teams, then can be shared. Bigger projects use multiple scrum teams working in parallel, that is there are various teams or scrum teams we can say that work parallelly. That for example one member or 1 to 2 members are facing some problem with the development of a particular product, then the second or 2 to 3 members of the next team can help each other. They can discuss the problem with each other and try to resolve them at best minimum time possible. So all these work together and form a final product. This product, when this is nothing but product backlog, that is requirement list created by product owner, ranked by the importance. Product owner can change items between sprints and release plan in built-in. We have already seen the definition of the sprint, that is completion of the given task within the time. That is nothing but the sprint. Okay, then after doing this, if there are some changes, then the product backlogs are sent to the sprint backlogs, that is it includes team selects starting from top of list. Team then breaks down into tasks, 4 to 6 hours of work per person per day. Commitment is fixed for this decision. No items are added until next sprint. So product backlog is nothing but the all the requirements. If there are some changes, these requirements list are made in the product backlog, and if there are some changes, these are handled by the sprint backlog, which includes that the team divides that problem again into different categories or components, and each component is handled by the different team of the development teams, and each member should work at least 4 to 6 hours to resolve that problem, and it that he or she should be committed to fix that problem. And No items should be included till the next sprint. So this goes on continuous till we get the final product which meets the user requirements. That is nothing but a retrospective. So this retrospective includes identifies areas of improvement, define action items for the next sprint. This is done by the stakeholders itself, that they test the product themselves, and if they found some problems or areas that are defective, then 2 weeks sprint is again been set. That is, within 2 weeks the work should get completed within the given changes. And daily, while doing this, daily 10-minute stand-up meetings are being held. The team reports what they did yesterday, what they are doing today, and any blocks in their way. So these all points are discussed in daily 10 minutes, in which in what in 2 weeks sprint. So basically the sprint is nothing but the, we can say, the time span in which if there are some changes in the product which are to be resolved, and at each after each development of the product the stakeholders give frank and find some empty spaces, or we can say identifies the areas where the work is needed, and again it they assign the sprint, that is 2 week sprint of work. Again the development team will work on it, that is sprint backlog, and again generate the next version of the product, which is again checked by the stakeholders. And daily 10-minute stand-up meetings are held. These are all about the Scrum model in Agile methodology. So that was all about the introduction of software engineering. We have seen the definition of software. So what is software engineering? Characteristics of the software engineering. Then we have seen different layers of the software engineering product, and we have seen different software process models. Then we have also seen the types of model, types of software. Thanks for watching today's lecture. Hope you like the video, and please do subscribe and hit the bell icon.